Okay, hi guys. So, Assalamualaikum and welcome back to my channel. Alright, so today we're going to learn subtopic 7.2, that is acid-base titrations. Alright, so we have this subtopic and then we have another one. Last one will be about solubility 7.3. Okay, so stay strong. Okay, for our learning objectives today, we will learn how to describe the titration process. So, I'm not going to go in too much detail for this stuff. Okay, distinguish between endpoint and equivalence point, because you guys already did lab tests and experiments, titration, so you should be familiar with it. Okay, then we're going to sketch and interpret variation of pH against titer value for titrations between, okay, these three types of titrations. You have strong acid, strong base, strong acid with weak base, and weak acid with strong base. Okay, and finally we're going to identify the suitable indicators for our acid-base titrations. So we will focus on these two because yang ni this will be something new for you lah. Okay. Alright, first of all, titration, you know that you will titrate your whatever acid or base, okay, from your burette into a conical flask. So, in your burette here, you have what is called the titrants, okay. So, the titrants is what you will control, okay, the amount, okay, you can control using the stopcock. And then add it into your analyte. Okay, analyte it can be either acid or base. So it will usually macam during your experiments you had your titrant to base and your analyte is acid. Okay, so so you are going to add your acid and base, and then you're going to get salt and water in your mixture ni when you add them together. Okay, so from your titration process, you can get two kinds. You can get data that are important for you to sketch a graph, or for you to sketch your titration curve. So, titration curve is a plot of the pH of a solution. Let's say if it's pH of your acid versus the volume of base added to the solution. Okay, so kalau acid punya kalau graph tu macam ni kan, the graph is like this. So, if this is pH acid, then this will be volume of base added. Kalau this is pH of your base, then this will be the volume of your acid added. So this depends kalau pH ni is what is in your conical flask. Okay, in your conical flask here. So volume added is what is the volume ni lah added from your burette, okay, into your conical flask. Alright, so let's see. Next, we're going to see what equivalence point is. So, ini ada kat dalam soalan lab test hari tu kan, online lab test. So, equivalence point is the pH at which the number of moles of your hydroxide ions added to the solution is equal to the stoichiometry allied to the number of stoichiometrically tak ada space ni, to the number of moles of, ya Allah, mabuk kot saya mesti, H plus ions originally present. So basically the equivalence point is when the number of mole of your acid, let's say HCl, okay, is equal to the number of mole of hydroxide ions, or you can interchangeably say your base. Okay, so maksudnya at that time, at that equivalence point, all your HCl is neutralized by NaOH. Okay, if HCl is in your conical flask. Alright, so that is the point where kalau dalam graph, you have a steep portion. Okay, atau macam ni. Okay, steep maksudnya dia, apa ni? Panggil gradient tu? High gradient large gradient sebab dia sharp increase macam tu. Okay. Okay. That is your equivalence point will fall in the range of your endpoint. Okay, what is endpoint pula? Endpoint is the pH value when the indicator just changes colour. Okay, dia baru je berubah warna. So, kalau endpoint awak, ingat tak? Kalau buat titration dalam lab tu, dia kata when you are nearing the endpoint, then you should drop your titrant, kan? Drop by drop. Betul tak? Into your conical flask. Macam mana nak tahu? When you see macam ada, kan nak guna phenolphthalein kan? Ada pink hue yang kejap ada kejap tak ada tu. Kan? Itu maksudnya you are nearing your endpoint lah. Dia just changes colour. Alright? Alright. So, that is endpoint. Okay? So, beyond endpoint, nanti lagi cakap. So, beyond endpoint tu, when kalau phenolphthalein awak dah excess in base kan? Bila awak dah terlebih base, right? So, then awak punya solution jadi basic. Betul? So, dia jadi betul-betul pink tu. Kan? Itu maksudnya awak dah excess lah. Maksudnya itu bukan equivalence point awak dah lah. Awak dah beyond your equivalence point. Okay? Alright. So, there are a few indicators that you can use. So, what is an indicator? So, for acid-base titration, your indicator will be a weak organic acid. So, dia acid, okay, that changes colour over a range of pH values. So, that means that your indicator ni, dia akan change colour when it is in its acid form, okay? And when it is in basic form, dia punya colour lain. Okay? So, between acid dengan basic tu, awak ada neutral point. Okay? Kat tengah ada neutral point. Right. That neutral point is awak punya when it is your equivalence point lah. Bila awak punya number of moles of acid is equal to the number of moles of high base. Okay. Alright. So, how do we pick, okay, which indicator to use? So, here you have 1, 2, 3, 4, 5, 6, 7. 7 types of indicators with different pH ranges. Okay. So, and they have these colours. Alright. Yang awak pernah guna is phenolphthalein. Dia tukar from colourless to reddish pink. Okay. Bila dia dalam acidic solution, right? When your phenolphthalein is in an acidic solution, let's say HCl kan dalam awak punya ni, awak punya conical flask ni. Okay, awak dah letak phenolphthalein. The colour of your solution is colourless, right? Okay, dalam ni ada acid. Okay, and then bila awak nearing endpoint kan, maksudnya awak almost approaching the equivalence point, then you will look out for what colour? Kat sini. Pale pink kan? So, pale pink, okay, is when is your endpoint lah. Okay. So, itu before awak access in base. Maksudnya awak just nice. Alright? Just nice the amount of acid dengan base tu. So, and then kalau awak terlebih letak base, terlebih letak sodium hydroxide, NaOH, then what will happen? Your phenolphthalein will change to reddish pink. Atau ada yang sampai purple weh. Memang salah lah tu. Kan? Kalau dalam lab test. Okay. Itu bila awak dah beyond your equivalence point. Alright. So, awak ada different pH ranges ni kan? So, that means awak kena pilih nanti awak punya indicator based on this pH range. Okay, right. So how to determine the suitable indicator for your titration? You are going to choose an indicator which the endpoint pH, okay, for your lies on the steep portion of the titration curve. So that means you have to see lah awak punya titration curve tu macam mana. Okay, this one, this choice ensures that the pH at the equivalent point, right, will fall within the range over which indicator changes color. Alright? Okay. What it means is that you're going to see the types of titrations you have. Okay. If you have, you are titrating between strong acid and strong base, okay, tak kisahlah mana satu acid pula, mana satu analyte, mana satu titrant kan, between these two, right? Kalau between strong acid and strong base, your pH jump, awak punya steep portion dalam awak punya titration curve will be like this. Okay, macam ni. Yang straight line tu, yang straight, yang tinggi tu macam tu. Before dia jadi curve macam tu. Okay, before dia jadi curve, this straight, this steep portion here, okay, this is called the pH jump. So, contohnya, kalau awak guna strong acid dengan strong base, maksudnya awak punya pH daripada yang awak punya range of endpoint for your titration will be from 3 to 10. Okay. So kalau macam tu, you can pick any indicator except thermal blue. So tengok thermal blue kenapa? Kenapa tak boleh guna thermal blue ni? Sebab awak punya pH range for thermal blue, it does not cover your endpoint, pH range endpoint for your titration. Sebab awak punya equivalence 3 to 10. So kalau awak punya color, awak punya indicator change color at this pH range saja, then awak tak boleh lah nampak perubahan dia. Faham tak? Awak tak nampak lah color change tu. Faham tak? Faham kan? Okay, boleh eh? Right, so kalau weak acid dengan strong base, you have your pH jump will be 7 to 11. Okay. Kenapa Awak rasa kenapa dia punya pH jump is at 7 to 11 ni? Sebab awak ada weak acid dengan strong base kan? Maksudnya, you will get what kind of salt? You will get a basic salt. So, kalau basic salt, okay, dan awak punya pH for your equivalence point, right? Your equivalence point, okay, for this solution, your pH will be more than 7. Okay, maksudnya basic lah. Alright. So kalau awak ada strong acid, weak base, then awak punya pH jump is 3 to 7. pH 3 to pH 7. Itu kat bawah kan? So maksudnya itu adalah sebabnya. Sebabnya adalah you have acidic salt. Alright. So your acidic salt solution, okay, the equivalent point, okay, for your pH, your equivalent point is pH less than 7. Alright. So maksudnya below 7. Okay, maksudnya dia acidic lah tu. Alright. So these are the suitable indicators for you to use. Okay. Right. So we have 3 types of titration curves, guys. So I don't want to lama sangat dekat sini. Okay. Kalau dia macam ni, awak boleh baca sendirilah. Okay. Tapi I'm still going to talk about it lah sekarang ni. Apa ni? Rambut. Okay. Alright. For strong acid and strong base. Okay. Your strong acid and strong base, okay, your pH, it starts low right here. Ni contohnya, maksudnya bila awak ada dalam conical flask awak, so that means your analyte, okay, your analyte is strong acid. This is your analyte, okay. Okay, so before the titration, so initially, right, when the volume of sodium hydroxide added is 0, your pH value is pH 1. Okay, maksudnya apa tu? Kalau pH 1 maksudnya you have, since this is a strong acid, so your acid will dissociate completely, ionize completely, okay, into H3O+, into H+. So awak punya H+ concentration is very high. So kalau H+ concentration is very high, then your pH value will be very low, right? So that's why you start off very low, okay, for this curve. Okay, and then when you add your sodium hydroxide, right? Your sodium hydroxide, your strong base, okay, that is your titrant, into your conical flask, okay? When you add it little by little, your curve will rise. Your pH will increase. Why? It becomes less acidic, right? So it becomes more basic. So makin lama, dia akan approach your end point. So awak tambah. Tunggu. Ni awak dah letak awak punya indicator lah kan. Sebab tu awak boleh measure dia punya, boleh nampak end point, color change tu. Okay. So when you add more sodium hydroxide, okay, into your HCl, your pH value will increase. Okay, it becomes more, bertambah awak punya base tu, and then it will approach the equivalent point. Okay, at this point here, right here. Okay, so maksudnya bila start straight ni kan, bila start straight line, okay, the straight line, okay, your straight line is the pH, is the titration punya endpoint pH range. So your straight line tu daripada 3 to 11 gitu, okay. So that is your pH jump. So approaching the equivalence point, okay, awak tengah tambah base, right, sikit demi sedikit, then you approach the equivalence point. So at this point, the number of mole of your sodium hydroxide will equal the number of mole of your HCl. At that point, okay, so for strong acid and strong base, you produce what kind of salt? Neutral, right? Neutral salt kan? And water. Okay, so since your neutral salt and ECl2, the sodium ion and Cl chloride ion will not dissociate in water, will not react with water. Therefore, dia tak ada pH value. So your pH value will depend on water punya. Okay, so that's why your equivalence point, okay, for the titration between strong acid and strong base will be 7. Okay, and your pH jump is from 3 to 11. Okay, that is when you have your steep portion. Okay, this is your steep portion right here. Alright. Okay, so awak dah capai equivalence point masa ni, and then awak add lagi 1 or 2 more drops of sodium hydroxide, and then terus awak punya pH shoot up. Okay, it shoots up, okay, above 11, okay, pH 11. So that means awak punya solution dalam awak punya conical flask ni dah become basic, because you have excess sodium hydroxide in your solution. Okay? Okay? Boleh? Okay, so maksudnya nanti later when you sketch graph, awak akan ada initial, okay, awak ada initial, and then you will have sometimes before your equivalence point. So at this point, at this range, okay, before equivalence point. And then you will have your equivalence point, right? Your equivalence point is when the number of mole of your acid and base is equal, okay? And then it will be different for different types of titration, okay? And then you will have, after you add excess of your titrant, okay? So it can be excess in acid or it can be excess in base. Alright? Okay, itu strong acid dengan strong base. So yang ni apa beza dia? Okay, beza dia yang ni kan, awak boleh nampak yang you start with a high pH value. That means awak start dengan apa? Maksudnya dalam conical flask awak tu acid ke base? Strong acid ke strong base? Siapa yang kat dalam conical flask awak? It will be your apa? It will be your strong base. Okay. So maksudnya awak start with pH value yang tinggi. Maksudnya awak letak indicator dalam ni kan. So pH value awak dalam conical flask ni lah punya. Okay. And then as awak add your strong acid, then awak punya pH will gradually decrease. Okay. And then you approach your equivalence point. Okay. So the pH jump will still be the same. It will still be 3 to 11, right? And your equivalence point will still be 7, okay? Because this is a titration between strong acid and strong base where you get a neutral salt, okay? Neutral salt and water, alright? So and then when you have excess acid, then your pH will be will decrease even more, and your pH will be less than 7. Okay, it will reach ni lah, ikutlah pH awak punya acid tu bila dia dah completely dissociated. Okay, so at these 2 points, okay, for strong acid and strong base, ni maksudnya strong base awak completely dissociated, so dia rapid decrease. Okay, so ini bila awak punya strong acid dah completely dissociated, so dia laju lah dia nak turun dia punya pH value tu. Okay, alright. So for weak acid and strong base, okay, mana gambar? Right, so right here we have our weak acid in our conical flask. Okay, weak acid. Okay, weak acid. Ingat tak weak acid macam mana? Apa beza dia dengan strong acid? Okay, ni sekarang kita ada kita punya burette. Alright, dalam burette ada strong base. So here we have weak acid and here we have strong base. Okay, so weak acid dia apa beza dia dengan strong acid? So your strong acid will dissociate completely, okay, but your weak acid will dissociate only slightly. Okay, if you notice here, okay, the initial pH is higher than strong acid, strong base titration curve. So maksudnya it's not as low as the one in the first one, okay, the first curve. So contoh tadi awak punya strong acid tu dia, okay, dia macam ni. Ni. Okay. Lepas tu dia naik macam tu. Straight macam tu. Okay. Tadi strong acid macam tu. Okay. Dia start even lower from a lower pH because it has higher acid concentration. So for weak acid, since your acid dissociate only slightly, partially, okay, ionized partially, then you start with a higher pH. Okay. One more thing. Okay. It gradually rise. A gradually rising portion of the curve is called the buffer region. Okay, it appears before the sharp rise to the equivalence point. Okay, which part is that? Okay, it is It is this part, okay? It is this part, the buffer region. So your buffer region tu maksudnya, kan awak ada weak acid. So dalam weak acid awak ada weak acid dengan its salt. Betul tak? Your conjugate base, right? So since dia akan buat, it is basically buffer, right? It is buffer solution, right? So your buffer solution tu dia nak try maintain dia punya pH. Dia tak terus naik atas, shoot up macam tu. So dia ada buffer region. Okay, maksudnya dia slow sikit lah nak rise tu. Okay, a gradually rising portion. Gradually, secara slow dia rise. Okay. Okay, so itu bila awak tengah lukis graf untuk weak acid, awak kena ada macam, dia macam slow lah. Dia bukan terus macam tu gitu. Okay, dia macam ni. Macam ni. Dia macam slowly, okay. Alright. So, since this is a titration between weak acid and strong base, that means that the salt that you will make is a basic salt, right? So you will have a basic salt solution. Okay, so basic salt with your water. Okay, because of that, your pH jump will be from 7 to 11. So ini 11. So 7 kat sini. Okay, that means your steep portion is right here. Okay, okay, this is your steep portion. This steep portion, okay, this steep portion, maksudnya apa ni? Apa saya nak cakap? So steep portion awak ni from pH 7 to pH 11 ni is when awak add your sodium hydroxide kan. Lepas tu dia terus shoot up macam tu before dia jadi betul-betul basic. Okay, that is your pH range for endpoint bila color, sebelum color change betul-betul. Okay, so that means for this one, for your weak acid and strong base, your equivalence point will be in the middle. Okay, your equivalence point will always be in the middle of your pH jump. Alright, so your equivalence point is right here at pH 9. Okay, in the middle. So pH 9 is your equivalence point. Okay, so you have 25 milliliter pH 9. Okay, awak punya equivalence point punya coordinate. Alright, so the pH at equivalence point is more than 7. Okay, because awak ada basic salt solution. Alright. Okay, boleh eh? So this is strong acid dengan weak base. So for strong acid and weak base, ni maksudnya awak ada strong acid kan? So you will start from a low, very low pH because high concentration of acid, because strong acid kan? And then when you add base, okay, the pH will gradually increase. Okay, and then you will approach the equivalence point. Okay, and your pH jump will be from 3 to 7. Okay, 1, 2, 3. Sinilah 3. 3 to 7 your pH jump here. So that means your equivalence point is in the middle here. Berapa tu? So it's at pH 5. Okay, your equivalence point is at pH 5. So when at 25 milliliter, your x-axis and pH 5, that is your equivalence point. Okay, so it is pH 5, okay, less than 7 kan, because you have an acidic salt solution. Okay, okay, alright. Okay, alright. Apa lagi? Oh, because you have weak base, so that means that your weak base will not dissociate completely. So it will dissociate partially. So that's why dia punya pH is not that high macam strong base. Kalau strong base kan atas sini kan, macam ni kan. So awak punya weak base it's not that high because yalah dia weak, so dia punya OH minus concentration is not as high as a strong base. That's why dia bawah sikit for your weak base. Okay. Right. So that is that. So yang ni saya tak ada graph untuk dia punya explanation. So awak boleh agak sendirilah. Yang ni dia terbalik je lah. Awak start with pH starts above. The pH starts above 7. So approximately 11. That means that you start with your weak base to your strong acid. Okay. Try lah lukis. Dia punya pH jump is still the same. Okay. Okay, so now we are going to learn how to sketch a titration curve. Alright. So firstly, you know your titration curve will look like this. Okay. Macam yang tadi tu, semua tu titration curve lah. So it will be a graph of a plot of pH against your volume of titrant added. Okay. Tak tahu titrant awak tu ikutlah dia HCl, acid atau base. Okay. So first, what you need to do is you have to calculate the initial pH of the solution. So when the volume of titrant is still 0, that means awak belum add any titrant. Okay, so it's just the value of your the pH of your analyte itself. Okay, it is different kalau awak ada strong species, strong acid atau strong base, awak just guna dia punya concentration terus. Okay, kalau awak ada weak acid atau weak base, then you will have to make use of the Ka given. Okay, ingat tu So first, you need to identify which of those acid and base belongs to the analyte. So, which is your analyte and which is your titrant. Okay. And then, you have to know, is it a strong acid, strong base or weak base. Okay. And then, you have to determine the type of salt that will be formed. So, after you know that, kan. So, let's see if ayat dia macam ni. In an experiment, 30 ml of 0.1 molar HCl is titrated with 0.1 molar sodium hydroxide. Kalau dia kata it is titrated with, maksudnya kalau awak translate dalam BM bunyi macam mana? Maksudnya HCl dititrate dengan NaOH. So maksudnya adakah dia titrate? Taklah kan? So maksudnya ini HCl dalam ni dititrate dengan dengan titrant lah. Dititrate dengan titrant. Faham? So, it is titrated with NaOH. Okay. So, ini NaOH awak. Okay. Lepas ini awak punya HCl. So, dah identify that sodium hydroxide is your titrant and HCl is your analyte. Okay. Identify whether it is a strong acid or strong base. So, what is the type of titration? So, dua-dua adalah strong species. So, strong base with strong acid. Okay. That means what type of salt that you will get? What type of salt that you will get? You will get a neutral salt. Betul? Neutral salt. Okay. So, awak boleh agak lah nanti dekat bila nak tahu pH equivalence dia, awak boleh agak dia punya pH. Okay, awak boleh agak dia punya pH, awak boleh agak dia punya pH jump. Okay, next we're going to determine the equivalence point. Ingat tak equivalence point tu yang mana? Yang steep tu, yang steep curve tu. Okay, so ni kan. So first awak kena ada dia punya pH yang low kan, lepas tu awak akan naik and then terus macam tu. Okay. So, your equivalence point tu kat mana? Dia nak tahu. Macam mana awak nak tahu? Oopsie. Madam. Okay. Alright. Oopsie. Okay, so how to determine the equivalence point? You will find the volume. Okay, find the volume at equivalence point using the formula MAVA over MBVB macam tu, atau adalah awak boleh guna ICE table juga. ICE pula ICF table. Okay, and then you can find the pH value. Depends on the pH of the salt. Okay, right. So maksudnya kalau awak tahu yang the salt that you get is a neutral salt, then you know that the pH will be 7. Okay, so the volume of your okay, kalau awak ada molarity yang sama for your acid and base, then the volume will be the same. Okay, to neutralize, let's say for your HCl to be neutralized, so kalau 10 ml, so if 30 ml of 0.1 molar HCl needs to be neutralized, it will be neutralized with 30 ml of 0.1 molar NaOH as well. So maksudnya volume awak 30, pH awak 7. Okay, so equivalence point awak ini, dia punya coordinate berapa? 37 lah macam tu. Okay, so this is your equivalent point. Kenapa saya tunjuk sekarang? Tak apa. So pH jump is the steep portion, your sharp portion, your sharp increase right here. Okay, it depends on the type of the titration. So ini strong acid, strong base. So maksudnya awak tahulah yang pH jump ialah 3 to 11. Okay, so the straight line, the steep portion will be from pH 3 to 11. Boleh? Okay, number 4, you're going to identify the final pH. Okay, final pH is, it depends on the concentration of the titrant added into your conical flask, into your solution. Okay, so basically selalunya ini akan jadi excess lah, excess of your titrant. In this case, it will be excess of sodium hydroxide. Okay, maksudnya nanti awak kena carilah pH bila awak ada excess volume of sodium hydroxide. That's why awak punya pH akan tinggi. So awak bukannya boleh agak-agak je nak lukis macam ni. You have to do calculations. Okay? Alright. So for the first example, tengok berapa minit. Okay, saya stop recording dulu. Lepas tu saya pecahkan this video into 2 parts. Okay, so this is part 1 done. We're going to continue with another video.